Well, greetings, everybody. So what you see here is a problem from my math lab that I'd like to show you. And if you want the short answer about this question, it would be this. This is a histogram where each bar of the histogram is located at the midpoint of the class. And the class width is 2. Notice how each midpoint is 2 spaces from any others on any other side. And so from edge to edge of each of these bars is 1. So if you want to know the class with the greatest frequency, it would be this tallest bar, which goes from, well, so if 40 is the middle, what would I get if I go 1 to the right and 1 to the left? Because it's asking for those class limits. Well, I'd get 40.5 take away 1, that's 39.5, and 40.5 plus 1, that's 41.5. So that's the short answer, without me being very elaborate about the explanation. Now, if you want some more detail about the explanation, here's what I think we should do. Let's go back and actually look at a different problem, and maybe think of this like review a little bit, and think of it like, well, I need to get my mind thinking about certain things before I learn this other problem, okay? So what I have here is a frequency distribution and a histogram that's based on that frequency distribution. The data here came from a selection of IQ scores from a sample of students. So I might look at this and say, well, 41 students had an IQ measured between 90 and 99, and 55 had an IQ measured between 100 and 109, so on. Okay. And then I'll also give you the midpoint each of those classes. How do you get the midpoint? You can find the midpoint by adding the lower class limit, 60, and the upper class limit, 69, and dividing by 2. Okay, so that's how you find the midpoints. And then over here on this graph, it's, the beginning of this class is 60, goes up to 69. The next class starts at 70 and goes to 79 and 80. And the height of each bar is the frequency. Okay, that's what we're looking at right there. So I give you a frequency distribution and a histogram based on that. Now, because I'm kind of starting with review, can you look at all that and tell me, well, how many classes are there? What's the class width? What's the sample size? And what's the relative frequency of the class that goes from 120 to 129? Okay, so maybe you could pause the video, think about what those are, see if you could figure it out. Okay, and then once we get squared away on that, we'll go back and look at this other example. But I thought it would be good to start with something like this before we looked at that other example. So you might pause the video and do that. In fact, I'm going to pause the video. I'm going to write the answers in. All right, here are your answers. There's 10 classes. Each of these is a class, 60 to 69, 70 to 79, so on. There's 10 classes. We divided all the data into 10 classes, okay? The class width is 10. So how's that? What is the class width? The class width is the number that you would add to any lower class limit to get the next higher lower class limit. So I might say, well, I know the class width if I can figure this out. What 60 plus what is 70? Or 70 plus what is 80? Okay? Or if you took the upper class limit and added the class width, you would get the next upper class limit. So you might say 129 plus what is 139? 139 plus what is 149? So on and so forth. Or it also works with the midpoints. If you take the midpoint of any class and you add the class width, you'll get the next highest midpoint. So 94.5 plus what is 104.5? 104.5 plus what is 114 plus 5? So either way you look at it, lower class limits, upper class limits, midpoints, if you add 10 to any one of them, you get the next highest one. That makes the class width 10. If that number's not obvious to you, you can take any one of these and subtract the one that comes before it. You'll get the class width, okay? So I found the class width like that with the lower class limits, upper class limits, or the midpoints, okay? Sample size, 200. How do I know that? Well, if 2 students had an IQ from 60 to 69 and 4 had an IQ from 70 to 79, then each of these being the frequency is how many students fell into that class. So if I just add all these numbers up, 2 plus 4 plus 14 and so on, then I'll get the total number of students that were in the data set, also known as the sample size. So if I add up all the frequencies, I get the sample size, that's 200. And then there's relative frequency. What does that mean? So let's look at the class 120 to 129. There were 30 students with an IQ somewhere from 120 to 129. So that's like 30 absolute students of the whole group. There were 30. But you might think of the relative frequency as a percent from the whole. If I take 30, the number that actually had that class, and divide by the sample size 200, I get the relative frequency. That's 0.15. So 0.15 is the relative frequency, but you might look at that like 15% of the students in the group had an IQ from 120 to 129. So that's a little bit of a review, a little bit of everything that from frequency distributions, and then the histogram is just a graph of all that. If 55 students had an IQ from 100 to 109, then this bar that is there from 100 to 109 goes up to 55, right? That's what it means. Okay, so that's a little bit of everything I think that we need to understand this problem, okay? Now, I get a histogram here, and it's a lot like the one I was just talking about, but there are a few things that are different. So here, the bars represent the frequency. If this bar goes up to 55, it means 55 students were in that class. But I notice here, these are relative frequencies, okay? So I might say, well, see this bar goes up to 0.25. So it's like 25% of the data is represented by this bar. That's what that means. Another thing that is different about this one, and a little bit maybe not obvious when you read it, is here in this one, where were the bars located? Well, the beginning of one class, and then it ends and it picks up with the beginning of the next class, like 60 to 70 to 80 to 90, 60 to 70 to 80 to 90. That's not what's going on here. Each of these bars on this histogram is located at the midpoint. Okay, see that mark right there? Right in the middle of the bar. Every single time, it's the midpoint. All right? Okay. Now, I noticed that this histogram doesn't actually have the numbers on it that I need as an answer. It says, let's look at question A. The class with the greatest relative frequency is, well, that would be this bar that's the tallest. That's what it's talking about. So it's this one. But it's asking me for the lower and upper class limits where I've got the midpoint. So I see this bar is right here. I see it's located. It's got a midpoint of 40.5, but it's actually asking me for this number where that bar starts to this number where it ends. How do we get that? Because those numbers aren't on this chart. How do I figure it out? So let's do this. I have told you that each of these bars is located at the midpoint of the class. Okay, so for example, the midpoint of that second class, or this one, or any of them, is the midpoint. Okay, but second class, let's say it's 32.5. This class that has the highest frequency, 40.5, and so on. How can I find the class width from that? Because we're going to need to know the class width. Well, I think I covered that a little bit up here, because I said if you take the class width and you add it to any midpoint, you'll get the next midpoint. That's one thing the class width does, and that's one way to find the class width. So look at this. I could say, all right, if I take any midpoint, subtract the one that comes before it, I'll get the class width. So I go up here and I'll say, oh, I use any of them. So I could take 32.5 minus 30.5. I could take 40.5 minus 38.5. If I subtract any two consecutive midpoints, I'll get the class width. So any midpoint minus the one that comes before it, I'll take 40.5. I'll take this one. I'll subtract 38.5, the one that comes before it. That's 2. The class width is 2. Now, the class width is the key to figuring out where any one of these bars begins and ends. Here's how we do it. We know the midpoints, and we know the class width. So far, I need the class limits. I need to know where the bar begins and where it ends. So I redrew the graph in a way that's like I'm zooming into it. I'm going to look right at 40.5 because that's the one that I know is the answer to this first question. Which class has the greatest relative frequency? Well, it's this tallest bar. It's this one. I'm just trying to figure out where does it begin and where does it end. So I redrew that with the 40.5 right there in the middle. So here's how you can figure out the upper and lower class limits, meaning where that bar begins, where it ends, consequentially an answer to our question. If you take the class width and divide it in half, divided by 2, and you add that to the midpoint, you'll jump up to the upper class limit. If you take the class width and divide by 2, and you subtract it from the midpoint, you'll jump down to the lower class limit. So what's the class width? It's 2. If you divide that in half, you'll get 1. So that's how far you got to jump up from the midpoint to get the upper class limit, or down from the midpoint to get the lower class limit. So if I jump from 40.5 up by 1, I get 41.5. If I jump down 40.5 by 1, let's see, 40.5 minus 1, that's 39.5. That's my lower class limit. That's how you figure it out. That's how we can start with the midpoints, find the class width, and then find the upper class limit and the lower class limit, which is where those bars on that graph begin and end, which is what the question's asking us for. Okay, so that's why in this question, as I worked on my math lab, I can say the class with the greatest relative frequency is this bar here, which begins at 39.5, has this midpoint there, which is not asking us about 40.5, and then ends at 41.5. So there's the answer to that first one. What's the class with the least relative frequency? Well, that's going to be the smallest bar, which is this last one. Now, again, I use that same procedure and I find the class limits for this last bar. How far did we decide you have to jump down from the midpoint to get the beginning of the bar and up to get the end? It was jump down by 1 and up by 1. So that'll be 47.5 to 49.5. 48.5 minus 1, 47.5 plus 1, 49.5. Okay, so that's A, is to find some class limits based on midpoints. Okay, what's the greatest relative frequency? Well, that's the tallest bar, the actual biggest relative frequency. Let's see, it goes over to 0.25. Okay, that means 25% of the data fell from 39.5 to 41.5. The relative frequency being 0.25 means 25% of the data fell within this range. What's the least relative frequency? Well, the smallest one. And I noticed that it goes up to that first line. What is that? It's not marked, but let's see. If that is 0.05, then each of these lines is 0.01. You can just count 0.01, 0.02, 3, 4, and then 0.05. So that lowest, shortest bar goes up right there, which turns out, if we count, 0.01. Okay, so that's how we can solve this one. It's tricky. It's different than I think some questions that came up before, because you have the midpoints and you have to work backwards to figure out what you really need to know. But in any case, I think it's a good problem because it gave me a little chance to review and remind you of some things and hopefully connect it all together for you.